Alright, yesterday we started graphing sine and cosine functions. Let's quickly go over what we know about sine and cosine. They are oscillating functions like a wave. Sine starts at 0, 0, goes first up at pi over 2, makes a dive up to 3 pi over 2, and then takes another rising position and stops at 2 pi at the same position 0. So this is called one period, and they ask you to graph sine function. You make picture one period of it and cut, paste, copy, paste all the time. So it's repeating itself all the time at 2 pi period. Cosine is the same, except it starts at 1, 0 at the peak point at height 1, and it takes a dive all the way up to -1, and then climbs back up to the original value 1 at 2 pi. This is one period of cosine, and they are very similar, sine and cosine. There is a lag of pi over 2. Cosine is following sine pi over 2 back. So it's kind of two waves going up and down, very similar shapes. Okay, we expressed these properties already yesterday. We graphed sine and cosine with modified numbers. What if there is a number in front? We have seen that this number in front makes your graph either higher or lower depending on the size of A. If A is big, you're really stretching it up. If A is small but still positive number, more than 0, it shrinks, it gets down, lower, like this. And if it's negative, you need to flip across x-axis. Alright, we graphed this. It was just really high up here like that. And this was really tiny like that because of the 1 over 4. And we explored what happens if you have a combination of numbers, one inside, one outside, B and A, respectively. And we have seen that B compresses or relieves the spring. This is like a spring. It pushes more in or out depending on the size of B. If it is a big number like 2, period shortens. So it makes more frequent up and downs, twice to be exact, because it's twice. And if it is small number 1 over 2, it makes less up and downs. Look, you see we have one hill, one bump, two bumps, two cavities in the original setup. Now you have one bump and one cavity, exactly half the shapes. Okay? And the right way to do this is solving this inequality again to figure out where this one period starts and where it ends is computed by this inequality. And we mentioned what amplitude is. This maximum from the ground level is called amplitude, or actually minimum sometimes. And it depends on the number in front. If there is no number in front, it's 1. And period is always computed by 2 pi divided by this number. Again, if this is 2, it shortens to pi. If it is 1 over 2, it widens to 4 pi. It takes longer to make that term. We finished this one, and we were about to see what happens if there is a number after x added or subtracted. Sometimes this can be an addition, positive or negative number. And there is a fourth number. Look, 1, 2, 3, fourth number on the end. Again, it's not always plus. If d is a negative number, it turns into minus. What happens if you add or subtract numbers inside and outside? Okay, this is gonna make the final, this is the most comprehensive form sine and cosine gets, most complex form it gets. It kind of covers everything. Okay, again, all you need to do is you need to sketch one period of action. It goes up and down, but how soon or how late depending on B. Okay, so you need to take this entire inside, not only x, not only b, bx minus c into middle right here, and set it greater than 0 and less than 2 pi. And when you solve this by adding c dividing by b, look, adding c dividing b, you experience that your starting value of sine or cosine is no longer at x equals 0. It moved to somewhere else. We call this as phase shift. Phase shift happened. Either right shift or left shift. We don't know. It depends on the values of c and b. But it shifted, not 0 anymore. And the period also changes to this value. This is the new period. But what is this all together? All three? This is the end of the action, up and down action ends at that value, wherever it is. But if you are wondering just the period, new period, you just need to take 2 pi over b. Okay? Phase shift CB, C over B. Period is 2 pi over B. Start is CB, end is 2 pi C over B. That's it. Let's put this into work in this question. Is it clear? So what we did here is just take the inside into middle and solve. That's it. There is no tricks here. Alright, let's do what I said right here. I put 0. I put 2 pi. What do I put in the middle? Yep, x plus pi. Right now, I'm focusing on picturing this. This is my focus, okay? So solve this first. Solve this part. And then, once I figure the picture of this, I will figure out what minus 5 does to it. Okay? Well, so I will figure out minus 5 later. This is first. First and then later. Okay. Now let's see what x plus pi makes to our function. Well, I will only need to leave x alone. So I will subtract pi from both sides. Right? Oh, look at this. It reads minus pi. This is start. X is in the middle. Fine. These are gone. And 2 pi over pi is pi. What is this thing? This is end. I want to see a picture here that starts at minus pi, ends at pi. So this picture is going to move, guys. Okay? Well, is there any shortening or compression? Are we gonna make faster up and downs here? What do you think? I see one dive, one climb here. One dive, one climb. Is it gonna be 2 dives, 2 climbs? Is it gonna make more frequent up and downs? In other words, is the period gonna be different? What is the new period? Is old one divided by b, right? 2 pi over b is always how you compute period. Here, for example, the period was 2 pi over b. What is b? 3. The period was shortened. And it was, I don't know, it was something like this. A lot earlier you finished this move, right? But here, again, I'm using this fact. New period is 2 pi over b. What do you think? What is the new period? What is b here? What is b? Yeah, it's the number in front of x. It didn't change. It's still 1. Like cosine x had 1. This is still cosine 1x. So the period does not change. So I will see the same number of cavities and bumps. Half bump, half bump and a whole cavity will be preserved. No more than this, okay? Make sense? So all we need to do is start and end values are different. So you're going to shift this into minus pi. Make minus pi. Where is minus pi? If this is minus pi over 2, minus pi is right here. So this is start. Where is the end? Pi ends here. So this green curve is gonna move into this 2 dots. So this dot is gonna move right here. This dot is gonna move 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 here. I will put it in dashed line because this is not our final picture. Yeah, terrible. Okay, I just shifted it left pi units. That's it. Didn't we know this already in 2.6? If you add values to x, it's a left shift. I already shifted pi units left. Okay, are we done? Is this our final result? Now, this is only, I made this part. We have a minus 5. So tell me what minus 5 does. So this is only cosine x plus pi. I need to bring in minus 5 in front of this thing. What does minus and 5 does? Yes, it's going to be 5 times scale of 5 is going to be stretched, and it's going to be reflected across x-axis. Reflection across x, 5 times stretch. You're going to increase the amplitude, the maximum values and minimum values 5 times. So this point is going to go 5 times up and then reflect. So I will first stretch it 5 times. Or I can't go too much high. I will put it here. This is my reflection 5 times. This is not going to change. Any point on x-axis stays on x-axis because it's 0. Y value is 0. When you multiply 0, y value, it's 5 times, still 0. This is gonna go 5 steps down, this point. This is gonna stay there. And this point is gonna go 5 units up. I will assume this level is 5, okay? Make sense? And then I will put this first. You see the stretching? This cup, this cavity is a lot deeper. It's like a vase. Cereal bowl you turned into a vase, okay? And this. Alright, this is still just positive 5 times stretch. I need to now make this upside down. So that point here is gonna go all the way down into minus 5. This is gonna go to minus 5. This is gonna stay there. This red point is gonna go to 5. And this red one will stay. It's not gonna reflect because it's on x-axis. This red one on the top is gonna go right here. Now connect the black ones. Alright, not too bad. Okay. This is it. Is it going from minus 5 pi to pi? Yes, minus pi to pi. Reflected, enlarge 5 times. Okay? Any questions? We need to identify a couple things here. Part A, what is the amplitude of this thing? How high is this from the ground? It is 5. What is the period? Did it change? No. How about shift? Did it shift it right or left? Did it? Yes. How much? This is how much? Pi units. Okay? It shifted pi left. C over B. Okay? And remember, you always take the opposite of this number. Look, it's reads C. This is minus C. You take opposite, positive C over B. So it's not just pi. It's minus pi. You pretty much take this entire thing with the sign. So phase shift is minus pi. It says C over B. C is opposite all the time because it's considered negative. So this is positive C. Alright? So take this number with the sign you observe here as phase shift. We already graphed it, so the mission is over. Let's try this on here. So the amplitude was 5 period 2 pi phase shift was minus pi Now we need to picture it. Which one is the right picture? It has to be a pretty steep one, starting at minus pi, ending at pi. Yeah, 5 is maximum. Is that correct? No, it doesn't start at 0, right? It's upside down. It's at negative 2. Not that one. Minus 5 I see here. I forgot the picture. So I need to have minus 5 going up, making a maximum at 0, going down, making a minimum at pi. So is that correct? Minus pi, minimum, going maximum. Seems like part B, but I just want to see everything is right. Nope, not this one. You need to start at the minimum. Nope, not that one. So it looks like it's B, correct? Do you all agree? We choose this. Alright, the key points are the points I make here in black. 1, 2, 3, 5 points here. They are start and end values. 2 of them are start and end values. The other 2 are x-intercepts. And if there are any minimum and maximums in the midway they make, you count them as well. So there are 5 in this question. But if there are more bumps and cavities, you have more maximum and minimums, you may have more key points. So you just need to enter these by coordinate divide. This is minus pi, minus 5. I'm not gonna do that. Pi 5. And this is what is this value? Minus pi over 2, right? Minus pi over 2, 0. This is pi over 2, 0. Look, it's right between 0 and this. It's halfway. And what is this maximum? 0, 5, right? Those 5 points will go right here. I just want to double check. Oh, I can't. Well, I can do solve it, but I don't want it. Yeah, let's do it maybe. Just want to make sure. Yeah, they want 1, 2, 3, 4, 5 values here. Minus pi, minus 5, minus pi over 2, 0, 0, 5, pi over 2, 0, 5, negative 5. Okay? Any questions? Alright, so this chart pretty much summarizes what we said so far. Again, if you are given a transformed sine or cosine equation with a, b, c, d with four numbers, it's been transformed, you can identify amplitude, phase shift, domain, range, period, how much vertical shift it has by just looking at these numbers. Again, amplitude is the number in front. Phase shift, how much you shift to right or left, is c over b. You're gonna take the opposite of this number. If it's plus, it's negative. If it's minus, it's positive. Period is found by 2 pi over b. And we figure out the full cycle where it starts and ends by solving this. You need to solve this to figure out where it starts and ends. Domain of sine and cosine, don't worry about that. It's always all real numbers. All numbers. This is special notation for that. And you don't want to worry about this one. Usually sine is between minus 1 and 1, but if you stretch it, it becomes minus a and positive a, like 5 and minus 5 we did earlier. But if you also have a phase vertical shift, a shift on the end, it's going to make it further up or down depending on the sign of d. This is kind of summary sheet, but you can already discover all these. Okay. Alright, this is a really nice comprehensive question now because we have 1, 2, 3, all four present. This was still a mediocre question because you had only 1 and 2 numbers here. There were 2 shifts or transformations happened here. Even we had the period the same, so it was kind of easy. Two transformations here. 1, 2, 3, 4 transformations all together. Alright, let's see how we work this. Ready? First, I want to figure out where this thing starts and ends. I want to focus on this part. I want to first sketch this. This is step 1. This is step 2. I will enlarge it 4 times. This is step 2. And finally, I will shift this. Which direction you're going to shift this? Up. Step 3. Up. Again, this is going to change period because of the number, and also there is a phase shift here. Period and phase shift will happen here. You're gonna shift right because of the negative, and period is going to decrease. So it's gonna make up and downs quickly, faster, more. This is going to stretch it, enlarge it, and this is going to move it up. I already can picture what's going on here in my mind. All I need is put it in paper, right? Can you visualize what's going on here? More frequent up and downs, right shift, enlargement, stretch, and go up. Let's do it. First, I need to know where this starts and ends. In all times, it would be just 0 and 2 pi. Now you have 3x minus pi. Add pi to both sides, all three sides. And divide. Alright, it starts at pi over 3, no longer 0, and ends at pi. So let's mark those values. Where is pi over 3? This is 60 degrees. This is 90. So it's 2/3 of that. 60 is 2/3 of this distance. 2/3. A little past half. Yeah, this is gonna be tight. Pi is where it ends. I already know where it ends. So this is start. Here is end. You're gonna squeeze this whole entire bump and cavity into these two red dots. Can you imagine that? Alright, let's compute the period. We'll need that as well. The new period is 2 pi over b. B is this number. Okay, so it's going to complete its full turn up and down on a range of 2 pi over 3. Alright, and this distance is already 2 pi over 3. So we're gonna make one full turn here between this and that. So okay, so why don't we start? I will first mark the midway. Where is the midway of this? Between 60 and 180. Midway is, add them and divide by 2, 120, right? Where is 120? Right here. This is right in the middle. 120. But I need this in radian. How many radians is 120? It's pi over what? 2 pi over 3? Is that so? 120 is 2 pi over 3. Okay? Let me clean unnecessary things. I don't want to see any degrees. When you are working, work with degrees, but later clean them up. So why did I mark the midway? Because in earlier, this picture would complete one bump right in the middle. One bump should be in the middle, terminated, and then a cavity starts from the middle. So this is easy now. Look, I'm gonna complete one bump here and one cavity there. Can you see that? Again, I need to make one bump right here and one cavity, same depth. Don't make it shorter than 1. I need to be precise. I need to stop at this level. I'm still off. Alright, this is the best I can do. Makes sense? Is it clear? Find midway and cross there. What is this value again? This is a significant value. It's 2 pi over 3. Now I want to find out where this maximum happens. And help me. A bump maximum peak point happens between these two dots. It's just basic math. This is start was at pi over 3, right? 60. This is 120. What is between 60 and 120? Right in the middle. So I'm off. The maximum should have been in that 90. So I should have met this guy here. Look, I can double check. I'm earlier. So my picture is off. I need to make the perfect maximum at 90. This is my maximum then. Like that. Okay? Here is max at pivot 2 and 1. Alright, what is the minimum of this then? This is 120. This is 180. What is between 120 and 150? 100. There's a 60-degree gap here. The midway is 30 more. 150. But I need it in radian. What is 150 in radian? Five pi over 6. Oh, I'm sorry for the tight picture. I should have picked a little bigger. But we have all the 5 points, 1, 2, 3, 4, 5 visible here, right? Can you see that? Because they're gonna ask for it, I believe. So you need to really spot them. How did I do it again? It's no brainer. Always go midway. One bump. The midway is between these two angles. Go find it by division. Add these two numbers and divide by 2. Add these two numbers and divide by 2. 120 and 180 makes 300. And divide by 2, 150. 5 pi over 6. Alright, this is just the beginning. We have just completed a picture of step 1. Now we are going to make this 4 times larger. Step 2. I'm making this 4 times larger. 1, 2, 3, 4. It's going to go up here. 1, 2, 3, 4. And it's going to make a dive right there. So this green dot is going to go all the way up here. Red dot will stay there. This dot will stay there. Stay there. Only these up maximum and minimum will go take a deeper dive here. So this is step 2. Almost. Is it clear? I'm now doing step 2. This is step 2. What is the new location of this point? It's still sitting at pivot 2, but the amplitude maximum is not at 1 anymore, it's at 4. This is 5 pi over 6, comma, negative 4. Alright? I don't know how to make the last one. You're gonna shift this whole picture 2 units up. Number 3 means every point here, 5 black dots moving 2 units up. So I'm going to kind of cheat, I think. Can I clean the earlier pieces so it can be much better? So I no longer need any of these previous ones. All I need is black picture. This picture needs to go 2 units up. This is going 2 up. And this is going 2 up. Yeah, I did it. And this point is going 2 up. U2. I don't need this anymore. and all these 3 points are going to up. So this is not a significant point anymore because it's sitting right in the middle. This is start significant, this is maximum significant. Now there is a significant value here. It was at 4, now it's sitting at 2. This is the significant value. Alright, I think we're done. There are 2 significant values here, there and there. Okay? Any questions? Alright, let's answer these. Amplitude is, what is amplitude? How high is this thing? Or once it's shifted, it may be deceiving, but the center of this wave, it goes up and down around this line. So you need to measure height from here to there, from 2 to 6. It's 4. You actually need to just look at here. Don't look at the picture. It's misleading on the picture. It's 4. Period is, compute the period again by formula. We already did 2 pi over 3. And phase shift is always this number, pi over 3. C over B. And C is this time negative, so we take opposite of it, pi. B is 3, pi over 3. How much we shifted up? 2, right? Vertical shift means how much up or down, sometimes if it's negative, but this is positive, up. Alright, key points are, you can, oh, they want these two. Okay, that's great. They don't want the intersections. So you just need to read these 2 values earlier. They used to be here, so you just shifted 2 up. What was this value, for example? It was pi over 3. Now it's up in the 2, so it's pi over 3 up. Pi over 3 comma 2. Okay? And this one, for example, no, I'm talking about, no, we need to first find the right picture, okay? Let's first find the right picture. It makes a 6 maximum, starts at pi over 3. Which one starts at pi over 3? This starts at 0, right? This is not. Wait, none of them are starting at pi over 3. Oh, that's why. Okay, this is what they did. They just, after you picture this, you have this up and down going everywhere, like this. So you need to predict where this is gonna go here, okay? Because it says, picture this, graph the function identify on pi over 3, it says. Oh, probably they didn't mark it here, but it's kind of a flaw. They want the picture from pi over 3 to pi, I'm guessing this value is not 0, it's pi over 3, it's starting at pi over 3, okay? All you need to do is look at what level you started off here. It was at 2, so it has to be starting at 2. I think this is it, or maybe the next one. But would we go down afterwards? No, we go up to 4. Start at 2, go up. I think this is the right choice. Okay? So it is number 3. Alright, the key values. You're gonna just read these values, okay? They're asking for this and this minimum, this again, 1 2 3 4 5. No, am I doing a mistake first? Why do they want these two values? They're not really key values.
They want the two shifted left. The two red dots that you have. They want.
See it again? We're missing. I'm missing something here.
Go back to the picture. Don't they want the two red dots in the middle? Don't they want the left one in the middle and not the middle one and the right one that you have?
They want these two, you're saying?
Yeah.
No, my question is, did we make the right choice in number 3? Pi over 3. It looks like their minimum. I mean, I don't know why they didn't give us these values. It looks like pi over 2 is here in their set. This is 0. Oh, okay. So just ignore this part then. No. I mean, this is misleading. They should have written something here. I thought this is pi over 3, but it's 0. No, this value is 0, guys. This is 0. So they want this part of the picture. Pi over 3 is here. So again, this second mark here is pi over 3, okay? So our picture starts at pi over 3, the first dot. So we made the wrong choice. So we are starting at 2, pi over 3 and 2, going up, down, up. So at pi over 3, I must be sitting at 2. No, not this. At pi over 2, not that. At pi over 2, am I at 2? Yes, but you're going down. So the right choice is number 4. Look, pi over 3 is here. I'm sitting at 2, going up, down, further down, up. This is the right picture. It's not our fault. The picture is misleading. They say picture from pi over 3 to 2 pi, pi over 3 to pi, but they pictured it from 0 to 2 pi. These pictures are from 0 to pi. 0 to pi, I believe. Okay, so let's do that with that assumption. So number 4 is our right choice. So they want these 5 values. I'm marking it. This, 3, 4, 5. Okay? Let's solve it and see. Right, we're done. Yes, as I said, pi over 3 is here. You see? What happened?
Oh, you click guide solution.
Oh. Again. You see, pi over 3 is this. They didn't start the other pictures at pi over 3. They started at 0. This is pi over 3. So 2, pi over 3 comma 2 is our first one. Maximum is pi over 2, 6. 2 pi over 3, 2. 5 pi over 6, and pi. Okay? So it's this picture is from 0 to pi picture rather than pi over 3 to pi. Okay? So this second part, this second notch here is this one. Alright, a little bit confusing, but we managed to get it right. Any questions? Alright, let's take a look at the last one. Now, what is different on this question? We don't have 4 transformations here. How many we have? 1, 2, look, 1, 2, 3. It looks like they didn't have nothing in front, but no, there is something in front. What is it? You will see next. First step we are gonna do in this question is, do you see this negative sign? We need to take care of it. We don't like working with a negative sign. I don't know what negative sign makes to our picture. So I'm going to pull this negative from inside to out. Is there a tool that can do that? Is there a way in Sine you can get rid of minuses? Yesterday. What is it called? If you have a minus sign in under Sine, you can pull it out. It's called odd function property of Sine. So I can get rid of that minus by simply pulling it in front. However, you can't just remove one sign from the first thing you see. You need to take minus from everybody inside Sine. So you first factor this minus out. Minus. Then bring this out. Do you see? Can you follow? So now we have 4 steps here. This is B. This is C. This is A. What is this? It's a flip across x-axis, reflection across x-axis. And this is a downshift. So I will first do this. This is step 1. And then I will flip it across x-axis. And later I will move it down. Okay? Make sense? So let's first compute where does this thing start and end. Take the entire thing to the middle and solve this inequality. Subtract pi over 2 from both sides. When you subtract 90 from 360, it's 270 or 3 pi over 2. Or you just set the common denominators. Okay? And I divide both sides by pi over 4, all 3 sides. Alright, this is a little bit tricky. How do you divide one fraction by another? Perfect. We flip the bottom and multiply. These two cancel, you don't have to flip. There. Here, let's flip the bottom and multiply. And cancellations are happening. It's between, there is no pi left for the first time. Interesting. It's between minus 2 and 2 times 3, 6. Did I do it right? It's between minus 2 and 6. But where is minus 2? I know this is pi over 2, this is pi, this is 3 pi over 2, this is 6 pi, it's 2 pi. Where is minus 2 and 6 in this picture? For this, you need to convert these into decimals. Take pi and divide by 2. Pi is 314. Take half of it, this is about 157, right? So where is minus 2 then? If this is about 157, 1.5, 2 is about, negative 2 is, this is 1, somewhere here. I'm eyeballing it. This is negative 2. Okay? Right? Look, if this is 1.5, this is about 2, roughly. Where is 6 though? This is 3, 6, 14. This is 628. Where is 6? A little bit before, right here. You're gonna put this picture, one bump and one cavity between these two red dots. Can you do that? Here you go. Oh, I need to mark the middle first. Where is the middle of minus 2 and 6? So I can finish the bump there. Don't just go blindfolded. Pick the midway between minus 2 and 6. Where is it? Just add them and divide by 2. Which is 4 over 2. 2. It's at 2. Where is 2? 2 should be between 1.5 and 3. Closer to 1.5 than 3 though. So it has to be somewhere here. So I'm going to complete my bump right between these two guys. Alright, but to pick the maximum of the bump, I need to go and find midpoint of minus 2 and 2. Where is between minus 1, 2? What is the midway between minus 2 and 2? 0. So bump, maximum of the bump happens here. So go make the maximum there. And go take a dive and cross 2. And what is between 2 and 6? I need to make midway. 4. This is where the minimum happens. You see, I'm not doing anything blindfolded. Everything is computer. Go split into 4 pieces. 1, 2, 3, 4. So you can mark minimums, maximum, and x-intercepts. One bump will happen halfway. Take another half. The maximum is there. The second cavity will happen another halfway. Half it so you can find minimum of it. Alright. So this is step 1. We're not done. Black dashed line is just this part, step 1, or this one. We need to now multiply with a negative. Multiplying with a negative makes this thing goes downward. So flip upside down. Flip it. and I'm marking significant values. This black dot moving here, this is gonna stay. Black dot will move down. 1, 2, 3, 4, 5 significant values. That's step 2. And step 4, final step. No, step 3, final step. We did these two. Is shifting this 3 unit down. Shift this 3 unit down. Alright. 1 will go where? -4. Let's go further down. -2, -3, -4. So we are moving right here. This will go -3. This will go -1. This will go -3. This will go -3 again. Agree? Now just make your final picture here. And significant values again. This is 4, -2. This is 6, -3. This is -4. This is 2, -3. This is -2, -3. All done. Okay? So let's answer these. What is the amplitude of this thing? Amplitude. It's the number in front right here. It's -1, but we take absolute value of it, it's 1 again. Amplitude still 1. It goes 1 up, 1 down, right? From the center. This wave is up, 1 down, 1 up, right? Alright, period is 2 pi over b. What is b? What was b? Pi over 4, right? When I multiply this, it's 8 pi over 4, no, pi. So it's just 8. Flip and multiply. It's 8. Period is 8. You don't have any pi. Do we have phase shift? What is the phase shift? It's this number always, right? Phase shift, b over 2c, b over c. So can I just call it -2? Right? Isn't it always that number here too? C over b, I'm sorry, C over b, but we get it by dividing this and computing this. This is the phase shift. C over b, which is -2. And what else is asked here? And vertical shift. And vertical shift is 3 down. Alright. Looks like we're ready. Check. Period is 8. Check. Phase shift is, what was it? -2. Check. Vertical shift is -3. doesn't say down or up, so I'm assuming negative will do that. If not, I will switch to positive, but it worked. Alright, next we will pick the right picture. Oh, this time we have the numbers, thank God they marked it. So we can match it to our picture. We start at minus, what is the leftmost point? Minus 2, minus 3. Which one has minus 2, minus 3? It looks like this is it. This is 1. Now everything is minus 2. So we need to watch for bump and cavities. We go down, hit 0, negative 4, all the way up for 2. We need to be going down. Wrong. Looks like this is correct, right? C is candidate. How about B? What is wrong with B? Oh, this is up 0. Okay. They are similar shapes, but these are on positive side. Wrong, wrong. So it looks like we have a winner, C. Alright, the key points are again negative 2. These are so hard to type. Negative 2, negative 3. Check. 0, negative 4. Check. What was the third one? 2, negative 3. Check. And
4, negative 2.
4, negative 2. And 6, negative 3. Alright. Did we get it right? Yeah. Any questions? No? We good? Alright, so just keep working on the practice questions and homework. I believe I'll see you on Wednesday in the exam.